Welcome to tonight's video on Unit 11 Part 4. We're going to be talking about how to find the area of regular polygons and composite figures. Couple of key terms. The center of a regular polygon is the center of the circumscribed circle, meaning like if you put a circle around the polygon. So this right here would be the center of the regular polygon. The central angle of a regular polygon is an angle with the vertex at the center whose sides are segments that end at the vertex of the polygon. So notice the central angle would be there, would be those two sides. So it would look, here's the center, and the central angle would be when you connect the center to the vertices of the polygon. The radius of a regular polygon, well, the radius goes from the center to the vertex, so basically these sides are the radii of the regular polygon. And the apothem is the distance from the center of the polygon of the polygon perpendicular to a side. So basically here, this right here is the apothem of the polygon. All right, so all of those are key. So in the figure, it says the pentagon PQRST is inscribed in circle X. Identify the center, so X is the center. The radius, well, either have two radii, they're XQ and XR. And then the apothem here is XN, because that goes from the center perpendicular to the side. And then the central angle, that is angle QXR. It's the whole angle here is the central angle. Now to find the measure of the central angle, well, this is a pentagon, which means there would be 5 sides and also 5 central angles. So if you go 360 divided by 5, you get 72 degrees. So that is the measure of the central angle, is 72 degrees. So you take 360 divided by the number of sides to get the central angle. 25 in the figure hexagon ABCDEF inscribed in circle G, identify the center. Well, the center is G. The radius, well, you have two radii. It's GC and GD. The apothem is GH, and the central angle is angle CGD. And since there are 6 sides, you go 360 divided by 6, which is 60 degrees for the central angle. All right, the top of the table shown is a regular hexagon with the side length of 3 feet and the apothem of 1.7. So it's 3 feet here, apothem 1.7. What is the area of the tabletop? Well, you have 6 triangles basically. And since they're a regular polygon, it would be the same. So it'd be 6 triangles times 1/2 the area of the, 1/2 base times height. So you have half of 6 is 3 times 1.7. And when you multiply to get together, you get 15.3 square feet. So basically, because there were 6 triangles that are the same, that's why you multiplied the area of one triangle times 6. All right, so to find the area of a regular polygon, based upon that, you take 1/2 the perimeter of the base times the apothem. So 1/2 the perimeter of the base times the apothem. So the top of the umbrella is shown a regular hexagon with side length 2 feet and apothem 1.5. What is the area of the entire umbrella? Well, the perimeter is 6 times 2, which is 12. So the area is equal to 1/2 12 times the apothem, which is 1.5, because the apothem is just the height of the triangle. So 1/2 of 12 times 1.5 is 9 square feet. The area of the regular hexagon here, well, we know the perimeter is equal to 5 times 6, which is 30. We just need to find the apothem. Well, in a hexagon, the central angle is 360 divided by 6, which is 60, which means each part here is 30 and 30. And then this would be 2.5, which means that the apothem, because remember this is a 30, 60, 90 right triangle, is rad 3 bigger than the smaller leg, so the apothem is 2.5 times rad 3. So the area is equal to 1/2 of 30, because that's the perimeter, times the apothem, which is 2.5 times rad 3. And when you multiply that out on your calculator, you get 37.5 for 30 times 2.5 times 1/2, and then rad 3 units squared. All right, here it's a pentagon, so it's 360 divided by 5 is 72, so that means each little part is 36 here. Now the hypotenuse here is 9. So what we have to do is we want to find the base there, and we also want to find the apothem, A. Well, to find the base, or sorry, to find the apothem, we can go cosine (36) equals A over 9. So 9 times cosine 36 equals A. So you get 7.28 equals the apothem. Now as far as x goes, well, x is opposite, so it's sine 36 equals x over 9. So 9 times sine 36 is going to equal x. So that gives you 5.29 when you type it in your calculator. Now for the whole side, you have to multiply that 5.29 times 2. So that gives you 10.58 for the whole side. So to find the area, we first have to find the perimeter, which would be 5 times 10.58. So when we multiply 10.58 times 5, it gives you 52.9. So the area is 1/2 the perimeter, which is 52.9, times the apothem, which we found to be 7.28. So now you have to multiply those together and divide by 2. So you get 192.56 square centimeters. All right, so let's look at number 30. Number 30 says, the dimensions of an irregularly shaped pool are shown. What is the area of the surface of the pool? Well, notice you have a rectangle, two semicircles, and a triangle. So the area of figure 1, well, we know it's a 32 by 16. So that's 512 square feet for just the rectangle. Now the area of the semicircle, well, and if we put 2 and 3 together, we actually get a full circle. So if we'll say area of 2 plus 3, which is the circle, remember that's pi times r squared. Well, the radius is 8, so therefore it's 64 pi. And then the area of the triangle, well, the base is 32 and the height is 15, so it's 1/2 32 times 15. So 16 times 15 will give you 240 square feet. So when you add it together, the area total is 512 plus 240, so that's 752 plus 64 pi square feet. And when you add that in your calculator, you get 953.062 square feet. All right, so let's look at the next figure. Same type of deal. We have two triangles. We have a rectangle and we have a semicircle. So the area of the two triangles, 1 plus 2, that's going to be 2 times 1/2 of 8 times 5, because notice the height of the triangle is 8 here. So it's equal to the 2 and the 1/2 cancel, so 8 times 5 is 40 square feet. The area of the rectangle, that is 18 times 8, which is 144 square feet. And then the area of the semicircle, well, that is, the radius is 9, so it's 1/2 9 squared times pi, which gives you 40.5 times pi. When you add them all up, you get the area is equal to 311.235 square feet. All right, so 32 says find the area of the shaded region. So we're going to find the area of the whole and subtract the area of the inner, and that will equal the area of the shaded. So the whole thing, if you look here, 25, 100, and 25 again, so it'll be 150 by 25, 20, and 25, so 70. So the area of the whole thing is 150 times 70, minus the area of the inner, which is 100 times 20. So 150 times 70 is 10,500, minus 2,000, and that gives you 8,500 square feet. The area of a kite is 120 square meters. The length of one diagonal is 15. Find the length of the other. Well, remember, area of a kite is diagonal 1 times diagonal 2. So 120, sorry, it's 1/2 diagonal 1 times diagonal 2 is equal to 1/2 15 times diagonal 2. So multiply by 2 to get rid of the fraction. So you get 240 equals 15 times diagonal 2. Divide by 15. And diagonal 2 is equal to 16 meters. All right, so a little review here. We have a rhombus, so remember that area is equal to 1/2 diagonal 1, which is 18, times diagonal 2, which is 22. So that's equal to 9 times 22, which is 198 square units. All right, here it's a parallelogram, specifically a rectangle. So notice we have a 30, 60, 90 right triangle. So since this is 12, we know that the other side, we know that a rad 3 is equal to 12. Divide by rad 3. And it's 12 divided by rad 3. So then you got to rationalize. So it's 12 rad 3 over 3, which is 4 rad 3. So that is the other side. So the area of this rectangle is 12 times 4 rad 3. Which is 48 rad 3 square units. So here we have a trapezoid, and remember the area of the trapezoid is 1/2 height times base 1 plus base 2. So it's equal to 1/2 of 5 times 28. Well, half of 28 is 14, so 14 times 5 would give you 70 square units. All right, and then the last one, it has an area of 55 square units. Find the height. Well, remember, area is equal to 1/2 height times the sum of the bases, which is 22. Half of 22 is 11, and then divided by 11 gives you that the height is 5 units. All right, that concludes part 4. Part 5 coming up next.